In this video, I'm going to do these 6 questions from the chapter surface area volumes, and these are for sphere, hemisphere, cube, and cylinders. These are the solid figure on which these 6 questions are based. So let's begin with the first question. The question says, if a sphere is inscribed in a cube, then the ratio of the volume of the cube to the volume of the sphere. So what can do here, let's say if I draw a cube first, and then inside a sphere. So if I draw a sphere inside such that it touches the boundary, right? So a sphere is inscribed in a cube and the ratio of the volume of the cube. So let's say if I say that, let's say L be the length or the edge over here. So from here you can figure out that the edge will be equal to the diameter, right? So we can say that the diameter is equal to L, and we can say further L is what? 2 times R, as you know that diameter is 2 times the radius. Now what we have to find out is the ratio of the volume. So as you can see, if I take the ratio, the sphere has come first and the cube. No, we can see that they are asking specifically the ratio of the volume of the cube to that of the sphere. So the cube will come first and then the sphere will come. So what I can do is to find the ratio. Now let's say V dash over V. I take the V dash as for the cube, which is what? L cube. And what is V over here is the volume of a sphere, and a volume of a sphere is what? Volume of a sphere is this, that is 4 over 3 pi r cube. Now check here, from this, right? I can replace L over here. So on replacing L can be written as what? 2 over 3. The cube of this is what? 8r cube. And that divided by 4 over 3 pi r cube. That's what we got. Now I can reduce this further. See, this r cube get cancelled. On further simplifying, what we can do is, this is 8. Dividing is same as multiplying with the reciprocal, right? So it will come as 3 that divided by 4 pi. This get cancelled over here. So it's 2 into 3, that is 6 over pi. So yes, we have an option, that is A is the correct option, as 6 is to pi as the required ratio. In this question, it says the volume of a sphere is numerically equal to its surface area, then the radius of the sphere. So we have to find out its radius. What we know that volume of sphere is what? 4 over 3 pi r cube, and the surface area of a sphere is 4 pi r square. So we can equate these two as they are given equal over here. So we can say volume of a sphere, which is 4 over 3 pi r cube, is given equal to its surface area, which is 4 pi r square. Now what you can figure out, that here I can cancel 4 and 4. We can cancel pi and pi. We have r cube times here and r square times, so 1 r will be left over here. So we can say this is r over 3 is equal to 1. That implies r is equal to 3 into 1. That is 3. So we'll say it's 3 unit and not 3 centimeter or 3 meters. So we can see that the correct answer is option B in this case. In this question, it says, in a cylinder, if the radius is halved and the height is doubled, then the volume will be. So what you can say, that if I take, say, that new radius as r dash, which is what? The half of the original radius, that is r over 2, the series r over 2. And the height, let's say the new height as h dash is what? Is doubled. So we can say the height will be 2 times the original height. Now we have to figure out with this new volume. Say V dash is the new volume and V with the original volume. So original volume should come as, what is the formula for finding the volume of a cylinder? This is pi r square h. So we can say that we have the original volume as pi r square h, and then we have to find the new volume, say V dash over here. It should be what? Pi r being r dash square h. So let pi be pi only. And I can replace this r square from here. It should come as what? Square of this, which is r square over 4. And what you can see that the height, which is h dash in this case, is 2 times the original height. It should be 2 times h. Now check, we can simplify this further and we can write the volume, say v dash, and taking this half outside the bracket, this is half, and what we have this as pi r square h. So check here, I can replace this pi r square h with v. So this is going to be half of v, right? So you can see that the volume in this case will become half on making such changes, that is on making the radius half and the height as doubled. In this question, it says the radius of a hemispherical balloon increases from 6 centimeter to 12 centimeter as air is pumped into it. What we have to find out is the ratio of surface area of the balloon in two cases. So we know the radius in two cases. Let's say if I find the radius of these two, say R1 as the original and R2 being the new one, it is what? 6 over 12. So since we have to get the ratio, let's reduce it. And now we can say that the ratio of the radii are 1 over 2. Now check, what we have to find out is the ratio of their surface area. And for a hemisphere, the ratio has to be this, right? We are dealing with total surface area. As you know, balloon has total surface area. Now, if I find, let's say S1 be the surface area of the first and S2 be the second, what you can see that the formula will be what? That is 3 pi R1 square that divided by 3 pi R2 square. So here 3 pi get cancelled. So we are getting what? S1 over S2 as R1 over R2 whole square. What does it imply? That S1 over S2 is R1 over R2 can be replaced with half. So it is 1 by 2 square. That is 1 over 4. So yes, we have this option. 1 is to 4 is the correct answer in this case. In the next question, it says a copper sphere of diameter 6 centimeter is melted and drawn into 36 centimeter long wire of uniform cross section area, and what we have to find out is the radius. So what we know that the shape of a wire, you should know that the shape of a wire is taken as cylindrical. It is actually cylindrical in shape. So we have this wire is equal to the volume of a sphere over here. So their volumes are equal. So what we can see that the volume of us, let's say the radius of this be r, and its length is what its height as h, and I took the radius of this sphere as capital R. So we know that their volumes are equal. So the volume of, we have the volume of cylinder as what? Pi r square h, and the volume of sphere as 4 over 3 pi r cube. So we can say pi r square h is equal to 4 over 3 pi r cube. Now check here, pi and pi get cancelled over here. Now we have the radius. You can see that the diameter of this is given. Diameter of the sphere, sorry. This is the diameter of this sphere is 6. So this radius is going to be 3 centimeter. This is in centimeter. And height is what I told you is the length of this wire, cylindrical wire. It is given as 36 centimeter. So let's check if I plug in these values over here. Let's say if I plug in these values. So we have to get r. So let r square be r square, and h is how much? 36 is what we got. So let's replace this with 36 is equal to 4 over 3 and r cube. The cube of this, that is 3 into 3 multiplied by 3. 1, 3 get cancelled over here, and this is how much? 9 into 4, 36. So this 36 can be cancelled. We get r square as 1. This implies r is equal to 1 centimeter. But then we have to find the radius only. Yes, so we have the answer over here. So that is D is the correct option in this case. This question says that if the radius of a sphere is increased by 10%, then the volume will be increased by what percent? Well, we can do it like this. Let's say if I take the new radius as r dash, so what we can say that the new radius is how much? 110 over 100 of the original radius. That's what it means to say when we say it is 10% more. So from here we can figure out that r dash over r will come out as what? 11 over 10. Now check here, we have to get the ratio of their volume. So if I take v dash as new and the v being the original, and applying this formula for the volume of sphere as 4 over 3 pi r cube. So it's going to give you what? 4 over 3 r over here is r dash cube, that divided by 4 over 3 pi r cube. Yes, we can reduce it. This get cancelled. And therefore we can write what? We can write the ratio that is new volume to the original volume radius is r dash over r cube. So from here we can plug in this value over here at this place. So 11 cube is what? 1331 over 1000, right? So we can find the percentage over here. So as you can see, it is how much more? The new volume. Right? If I talk about the new volume, this is how much? 331 over 1000 more than the original, using the concept of ratio. And by percentage, how much it should be? That is, if I multiply it by 100, placing a percentage sign, that comes out to what? 33.1%. So that is the new volume will be 33.1% more than the original volume.